next phase of us getting from our conceptual stage to our logical schema's completion is to actually convert the ERD to a schema. So this will actually look very similar to the ERDs, but it's actually going to be more helpful for the process of normalization, which will be the last phase here. So we're going to lay out our entities like columns of the table. So you can look at the picture here and you see that we have an entity named customer, an entity named order, an entity named order line, an entity named product. So all of our entity names go on top of the row. Each of those boxes it's just like if you looked at a Excel table and didn't have any records in there and you just had the column headers. That's basically what it looks like. At least that's how I think of it. You'll note that the primary keys are still underlined, just as they were in our ERD, and our foreign keys have those dashed underlines. The arrows are a little funky because they go up from the foreign key to the primary key. And before we were thinking about from the primary key to the foreign key going like with gravity, right? This time we're going the opposite way. So that's one easy error to catch yourself from making. Those arrows are very important because sometimes you'll see people be a little lazy with their dashes or underlines, or they'll their naming conventions will make it very confusing. So the arrows are very important to make sure that we know which one is the foreign key and which one is the primary key. Our associative entities have arrows going away from them. So you look at order line, and you can see that order line has a primary key from order ID and product ID. This particular example uses a composite key. So instead of and those are foreign keys. So instead of having a order line ID and having order ID and product ID be foreign keys with underlined, they've turned the two of them together into a primary key. So note that they're solid underlined, even though they are foreign keys, because they're being used in this way. Yes, so this is a basic, very small schema, and we're going to go through basically each of the types of entities that we've talked about first, and then the relationships, and talk about how to transform each of these different types. So for our regular entities, we do just what we talked about. So you can see the customer ID maps down, the customer name maps down. For composite attribute, you can see that the street, city, state, and zip have made it down into the columns, but we don't have a separate one for customer address. And that should make sense because if you wanted to store this information in a table, you wouldn't have one column say customer address and then separately, like redundantly, have the city, street, state, and zip, right? So when we convert this to the schema and map it down, the composite goes away. All we get are the actual final attributes. For the multi-value attributes, these are a little funky. So you can see that you actually get two tables out of this. You get the employee table that has everything except for the multi. And then you get the second table that has the employee, or the primary key from the employee in this case, and then the skill, which is our multi attribute. So this is the way that you can avoid having trying to put multiple values in one cell and stuffing it all into the employee, because we can't do that. So for my D&D question before, when everything was in one table and messy and awful, in here, if you had somebody who was a rogue and a fighter, you would see them listed twice. So you'd see them listed twice in the employee skill, and then it refer back to the employee main table, if that makes sense. So your bottom table is the foreign key. That's the one to the many. They have many attributes. That's where you'd see the doubling up of the data. So our employee table would still have just one line for that one character. Next, we have weak entities. Remember, these are a little awkward because a lot of times they don't have their own primary key for the dependent. So you can see here that the employee ID became a foreign key on the dependent, and then they combined the first, middle, and last name plus the employee ID. All of that together is a single primary key. Why is this maybe not such a great idea? Because we have 4 different columns all acting as one huge ID, when we could just have a small numeric one that is easy to find. So this is a valid way of doing it. A better way of doing it, or more efficient way for a larger database, would be to add one more attribute on here for the primary key for the dependent. So you can totally do that. Anytime you see a composite key, you can always do that in order to increase the speed of your database. Other than that, it's a little hard to tell looking at the schema that it is a weak entity. If you'll notice, there's no big red sign that's saying this is a weak entity.